Hello all and welcome to a new video on Code Tech Tutorials. Today we're going to be talking about programming with the openal library. This is a sound library. In this very first tutorial we're only going to go over the basics. We're going to basically get to playing small sound effects. So if that's all you want for your game is to play sound effects like jump sounds, attack sounds, or whatever, this first tutorial will probably be enough for you. But what openal can do is a lot of tuning distance and making reverb and all kinds of effects and 3D sounds, positional sounds for surround sound, so that if you're in a 3D world or you want sounds to change as they get further away from your character, and so you can tell if they're on your left and right and all that sort of stuff, openal can do all of that. And we will get into that in some of the later tutorials. But in this first one, we're simply going to be setting up devices, like just making sure it actually finds your sound devices, loading up a small sound effect and playing it back on your speakers. And first of all, I just want to show you some of the references I use to get started, just in case you get stuck and this video isn't enough or whatever it may be. Then Matrix made a video tutorial a while back. Let's see here, it's like from 2016, and they're not bad. There's only 4 videos. That's probably about how many I'll do too, 4 or 5. But his are in the lightweight Java game, whatever. It's in Java. You basically have to translate it to C++ code, and it's a little different. There's their main website, just openal.org, which has a whole lot of stuff and a whole lot of info about it. There's also Indie GameNet, a complete guide to openal with C++. Now this guide is actually pretty good, I will say, but this first guide, this isn't about playing a sound. This is about, do you know template metaprogramming? Because if you don't, you're not going to understand this code, which most new programmers don't, and it takes a while to kind of get a grasp on that sort of thing. So I think this tutorial, while it is really good technically, the assumed knowledge is a bit high for new coders, and I feel like tutorials should be guided at new coders. So yeah, sure, you can copy paste all this code in, it'll probably work, but you're not going to understand it, and that's where things get ugly. Because yeah, there's these template, he uses enable if, which is a bit difficult to understand, especially for new coders. So I'm going to do all mine in a very simple base of code. So yeah, no template metaprogramming in what I'm going to do here, and that's going to be the big difference. But other than that, actually, this guide here really helped me. So if you're already pretty advanced, maybe going through this guide would be better than my videos. I'm not sure. That's up to the individual. And let's see what else is there. Okay, well, they have a GitHub repo, openal-soft, and in here, of course, is all the code and the library, so you can compile and link the library yourself. We're going to be using vcpkg manager, though, which is basically going to pull down this and link it. It is important to know that they do have examples, and in these examples, you will find some pretty good bits of code. If you're used to OpenGL already, this is probably not that bad. One of the big things in here that I used that I didn't really see elsewhere was that in their loader they have a pretty nice set of stuff for loading sounds, and I'll go through that when we get to the code. So this is just another good resource if you get totally stuck or just want more examples. Yeah, there's a lot of options for sounds, but I'm just going to be using some from opengameart.org because they have some that we're allowed to use basically, and we'll use some spell sounds to play around a little bit here with the code. Last but not least, there is the openal Programmer's Guide, and this is huge. It's 142 pages, so yeah, you can really print out this book if you want, but it's basically got everything about the library. It's a lot. There's a lot you can do with this library. We are going to be using Microsoft Visual Studio, and we are going to be linking this library with VC Manager. I have a lot of videos on libraries on my channel. The VC Manager is probably the quickest and easiest way to get it all linked and ready, but you can manually do it. I've done videos on how to manually do it. You could download it from GitHub, compile it, and link it yourself. Or you could do the VC Manager stuff, which I'm going to do. So I'm just going to launch my command prompt, go to where I have VC Package Manager. My last video right before this is one on VC Package Manager, so if you're completely lost on that, you can follow that, or just search it, and there's some decent documentation on how to get it started. But with Windows, this makes it really easy. We're just going to be sticking with Windows and the most popular development environment, Visual Studio. So alright, let me do this. Okay, so what you want to do is vcpkg search openal, and you'll see you get openal-soft. So this is what you want to install. You also, of course, want to make sure you get the right version. We're going to be doing all 64-bit, so we want to make sure we get the 64-bit library. So we'll just do vcpkg install openal-soft x64-windows. Oh, I spelled install with an E apparently. There we go. Already installed. So this, when you do this the first time, it'll take a while. It'll compile and set everything up. But another thing you want is, well, let's see, vcpkg search sound file, SND file. We're going to be using this to load the data from a sound file, basically, to just get that binary bit of sound. So OpenAL needs to know about your sound somehow. Sure, you could do it manually with C++ code, and actually one of those tutorials, he actually has some code in here on how to do it manually, but it's this live sound file will do it all for us, so it's just going to be a lot easier for a new user. So we want to install that too, x64 Windows, and I've already installed it. So you know, launch Visual Studio. We're just going to do a new, just a new project. We'll just do a brand new project. We're going to start it empty. And we'll just call this openal IMPL for implementation. And I will host this, so if you can't be bothered to watch a video and the walkthrough of how everything goes, you could just go straight to the link. I just ask that you give this video a thumbs up before you leave if you're going to do that. Alright, so we get a new solution. Let's just set up some stuff initially. We said we wanted to do 64, so let's switch this up here to 64 to make sure it compiles with that and uses our 64-bit libraries. So we have our solution over here, and I'm going to click show all files so I can see everything, and there's no files because this is an empty blank project. So what we're going to do here is we're just going to add, let's see, how do we want to do this? That's the question. So it's just going to be a standalone app, but I'll make classes of all the stuff. We need a main, so let's make a main. Of course we need int main, return 0. So let's make the classes. So I'm going to go over here, add some new classes, new class. And we're going to have one called SoundDevice, and this one is basically going to initialize our audio. I'm going to just hide my cam, type all this out, and then I'll explain it after the fact. Okay, now that we've got a SoundDevice coded up, what we can do here is just go over this real quick. I made it a singleton. This doesn't have to be a singleton, but often it makes sense for this to be a singleton because you don't want to have multiple instantiations of this, because this initializes our SoundDevice. If you have multiple SoundDevices and want to initialize them differently, yeah, you might want to not make the singleton, because ultimately pass this null pointer to open device, it gets whatever the default is. So you can actually query and pass in a string of the name of the device you want to open if it's different than your default. But in our case, we're only going to open our default device. We might talk about switching devices later. There's some code actually on this tutorial here about it, about getting the different ones. So just FYI, get available devices. So here's some code right here that returns a vector of all your devices. So you can go over those and then pass one of these device names instead of null pointer to open that device. But we're not going to do that. We're sticking with null pointer in this particular tutorial. So next we just want it to set up a sound buffer. Let's go ahead and get to coding up a sound buffer. Okay, now we've got all this sound buffer coded up, so I will just walk through it. In the header we have, well, this is yet again a singleton because we want to keep track of all our sound buffers with this one class to manage everything we've uploaded to our memory. So that way, if we want to unload some sounds, we can do that. And if we, I just don't want to have multiple classes handling it. To use this class, you just need to call the static get method, and that will initialize it, which it doesn't really need to do anything to initialize. The device is already initialized. That's handled by this other class. So anytime we load up a new sound effect, we're going to add it to this vector of ones we've loaded. And anytime we remove a sound effect, we're going to remove it from this vector. And whenever this class gets deleted, so when we exit our program, we're going to delete all the buffers. So this delete buffers removes it from memory, and that's going to just take care of all of them at once. So to walk through some of these functions, okay, there's the get, it's pretty standard static method. So our add sound effect. Now this is actually copied from someone else because I don't necessarily think that I can do it better easily. So I'll just show you where I've got that from. That is actually from this openal-soft examples. And if you go to this play one, they have, you see they use sound file here, which is what I'm using as well. And they have a load sound function. I'm using essentially the same function, which basically just grabs the sound file from this file name and uploads the data and then returns the access integer. So that's where that came from. I like it a lot better than the one on indiegamedev.net. It's a little simpler with that library. So we got everything we need here just as temporary stuff. I did have to make a few changes here from that for this to work because there was a few things that didn't want to compile. Here, this one here, this buffer is going to be our return value, and we've got some error in formatting just so we can make sure it gets uploaded properly because this checks all of that. So the first thing we do is we use that sound file library to open it, make sure it doesn't fail, make sure it has actual frames, and we check the format here to make sure it's a good format. Then we allocate all that memory into our membuff pointer. Now I had to do the static cast short because it was throwing an error. It's probably just my compiler here. It didn't like having a void pointer assigned to this short pointer, so the static cast short was one change I made that was necessary. Short star rather, not just short. Then we just go through the rest of the stuff we need to upload, but here's where it actually uploads. We generate a buffer that is this integer here, and then we upload our data with this buffer data. So anytime you upload a new sound, you need to generate a buffer, and then you need to buffer the data. As you see, this takes the format, the membuff of the actual data, how many bytes, and the sample rate. And then after all that's done, we can free this membuff because it's already been uploaded, and then we can close our sound file. And then it does a last check for errors. We're going to add that buffer. This buffer is just the unsigned integer that we need to know about to access it, to access our sound. So we're going to push that onto our vector so that we have a list of known buffers that are currently uploaded, and then we are going to return our buffer so that we can actually use it in our program. So we need to save that somewhere. And let's see, remove sound effect. All this does here is if you want to unload a sound effect from memory, you can just pass it which buffer you want to remove, and it goes ahead and calls delete buffer on the one if it finds it, and we're also going to erase it from our vector and return true if it was able to erase it, return false if it was not able to erase it. And also here we have a destructor that deletes them all at once. I think I already talked about that. Okay, so in our main, to actually load a sound, this is going to return the SoundBuffer class. And then this adds, which then allows us to call this add sound effect. And this add sound effect is going to return a integer, an unsigned int. So it's a uint32t, which is what the AL uint is. It's a 32-bit unsigned integer. And we'll just call this sound1. So let's actually get a sound here. I've got a whole bunch of sounds already downloaded. Alright, well we could use any of these. These are all just OGG files, and these are actually from Sound Starter Pack from OpenGameArt. There's a whole bunch of them. You can unpack them, you can use any of them. But we just want to get the actual path to one of these. So it'll be like So that should handle getting the sound. So at this point, we'd actually hit play on our program just to make sure it compiles. We could do a got here just to show that we went through the code without any errors. So just to make sure it actually runs, we can go ahead and do this. But the last part here is coming up, and that's actually playing the sound, and I will show you how to do that here in a second. Okay, starting. It does say it opened on my high definition audio speakers. That's my default device, and I got a could not open download spell, and it looks like it's because this backslash. If we're doing this backslash, we need 2 of them. Otherwise, it's doing something else. There we go. It didn't throw an error in loading the sound, so it did actually load the sound that time. And now the last thing we want to do is actually play the sound, and to do that we need a sound source, which is basically like a speaker. Later on we will have listeners as well. This is a 3D sound library, so what you can do, and what we will get into later, is positioning sound. And when you position sound, you need to know where the listener is. But we're not going to mess with listeners on this tutorial. We're just going to get a source, and it's going to sound like a general sound coming from your speakers. It's not going to be positioned. Alright, so let's do it. Let's make a source. Okay, we've got that all implemented. Now all we need to do is make a sound source. We'll just call it my speaker, I guess. Actually, that's all we need to do. Boot it, of course. And we'll go my speaker dot play, and we want to play the sound one that we loaded up. So if we run this right now, the program is going to exit immediately because it's going to fly through all this. And this actually does it on a separate thread natively. That's just how openal works. It'll play the sound using its own threads. It'll handle all that for you. But if you exit your program right after you play, you're not really going to hear the sound. You're just going to return 0 right away. So usually you have this in a loop, with your game or whatever running, so you actually hear your sound. But in our case here, I'm going to have to put in a little hack. So in my sound source, let me walk through this code and I'll get to the hack. It's this code I commented out. That is sort of the hack. Okay, so pretty standard class here. When we play it, all we need is the which buffer to play. So it needs to know how to access it, or which one to access in the memory of uploaded stuff. This has to be one that's been uploaded. We're holding some private variables, and these are just like your speaker variables basically for the sound. I guess some of them would be like a mixer board type thing, because you have a pitch. We're just leaving it default of 1 pitch, so it's not like slowed down or sped up. And we have a gain, which is basically your volume. Volume 1 is the default. It'll play as it is. And we have positions. We're just setting these all to 0 right now. This is basically the location of your speaker. We'll mess with that in later tutorials. Velocity here. Velocity is for moving sounds. Basically, we'll get into that more later, but we're not going to have it moving, so it's just 0. So you can basically have it like going in a direction for maybe a car whizzing by. And whether we want to loop the sound or not, we're going to keep this false. We just want to play it once. And this source is stored variable. Basically, this speaker is also uploaded into memory. And the only thing we have to access it is this integer. in this buffer here is basically what we've last played. If it's 0, it hasn't played anything. So now let's go over to the implementation to take a look. When we set up this class for the first time, we're going to populate this source. So anytime you instantiate a new sound source like we did right here, it goes ahead and it sets up a speaker because of this constructor. So it gens the source and it sets the pitch, gain, and everything to our defaults. Let's see, when we destroy this class, we want to delete our source, which is basically our speaker here. We want to delete that out of the audio memory. And let's see, this play function is the big one. It's the main thing. So anytime we hit play on the speaker, we're going to tell it which buffer to play. Now, as a bit of an optimization, I like to see if it's changed. Then we're going to set it to whatever you told it to play, and then we're going to upload that as the buffer. If it already is what you told it to play, then we don't have to upload this data and just play the source. So let's go ahead and give it a go. Valid float property. Little error there. We'll fix that in a second. Okay, so all that error was we were buffering an integer as a float. This should be source I. So what we want to do to make sure the sound actually plays is we just want to block the thread, since we're not in like a loop where the program's going to continue. Yeah, we're just going to do this little while loop while it's playing. So we have a state, and this sets the state as it goes, and eventually it'll set to not playing, I believe it. And once it's anything but this playing, it'll actually exit and the program will exit. So now we should hear our sound if everything is going good. Yep, there we go. That was our sound. So that's just a plain old spell. We could load up any little sound effect here, anything you want. And you could add multiple, like, I don't know, we could just do like sound 2. We could pick another spell here, whatever this is, magic fail. Sound 2, and then we could do sound 2, and they should play one after the other. Yeah, we could do it on the same speaker. It's actually fine. We could also make separate speakers for these two. There we go. Well, let me know if you have any questions about this first episode. I will upload the code link down below. If you have any suggestions, you're welcome to leave a comment, but also you're more welcome to just edit the code and make a pull request. So if there's something that is like terribly, terribly wrong in this code that you see, because I'm not perfect, I love C++, but as with any C++ coder and any coder in general, our code's never perfect. You know, if you see something you can fix, cool, fix it. And as we go along, hopefully this code can stay maintained well. And look forward to episode 2, where I'm going to get into the next part of this. I'm not sure if I'm going to do streaming or listening, because those are kind of two big subjects, but I'll try to cover just one subject onward from this. I know this one's pretty long. This is probably going to be the longest one. At least that's my intention. Also, I do have a Patreon. If you want to be involved further in the community, you're welcome to join that. We have a private Discord, so if you want to talk to me every day, I do check that Discord daily. Also, I'm going to put up some threads on Patreon about what the community would like me to focus on next. So right now, I'm basically just doing whatever I feel like as I get some supporters over there on Patreon and put some voting up about what to focus on. I can actually have some guidance on where the most supportive of my community would like me to focus, and whether it be libraries, video editing, or whatnot. I will oblige based on how that goes. Thank you all for watching. Thank you for any and all of the support. Hope your coding goes well. I'll see you guys in the next episode. Matt from Code Tech Tutorials, over and out. Peace, guys.